What's up, y'all? My name is Pepe. We're at Albert J. Black in social media, and welcome to the second video of Mastering Blockchain series. Today, we're going to learn a little bit more about what blockchain is and the decentralization that occurs within a blockchain. Just keep in mind that not everything needs a blockchain, and not everything needs to be decentralized. Before going into the juicy details of what a blockchain is and how does it work in its entirety, we're going to go through the systems and what we need in order to have a blockchain, a truly decentralized ecosystem. Before going into the centralized systems, we need to know the basic systems, the traditional systems that use the usual technology that we are accustomed to. These systems mostly are centralized and distributed. Centralized is just like Facebook or Google. Well, some of their technologies. For example, it's a single authority, let's say, I don't know, me, that I have a website that you guys can interact with. I am in control of the client and the server side. For example, you are the client in this case, but I control what you can see, what you can interact with, and everything that's related to your relationship as the client with my server. That is centralized, just one way from my part and one way from your part. But when we go to distributed systems, yes, this we talked about earlier. It's the base of blockchain, but it's still centralized because one authority is in control of all the nodes. That's basically how it looks. A centralized system is the authority, is in control of the client-server relationship and everything. But a distributed system can have multiple nodes, and each node has its own operations and all. They all produce a single result, for the user to see. But still, both of these have an authority, even distributed systems and centralized systems. We already talked about centralized and distributed systems. Both are centralized. Now, let's talk about what you guys came here for. Let's talk about blockchain, how it works, and their technology. Now, I'm gonna tell you when to use blockchain. There's a few metrics that I learned from studying blockchain, but of course, you can create your own. Basically, you go to blockchain technology when you need data to be immutable, when you need data that once it's created, it cannot be changed, when latency and data throughput are not required, meaning speed is not an important requirement. It is, of course, but it's not the most important thing. Then you use blockchain. When you need decentralization, especially decentralized updates, what do? You can use blockchain. When user trust does not exist in the ecosystem, what do? Of course, you use blockchain. When anonymous users exist and does not exist, you can use blockchain in both cases, but you can choose a public blockchain if anonymous users are anonymous. Or if users are not anonymous, you could use a private blockchain. In all of these metrics, you decide when and how to use blockchain. The next step would be how to actually implement blockchain. 3, 2, 1. If you want to start creating blockchain stuff, first you have to ask yourself these questions. What? Level, beaching, security. In short, what is it that I'm going to decentralize? For example, money transfer. I want to decentralize the transfer of money. What level of decentralization this will require, and how will I achieve it? Contest. It's like mining. All miners are in a contest against each other, and the first one to solve for the nonce gets the rewards. I will explain this later down the road. What blockchain am I going to use? For example, you can decide to use the EOS blockchain, the EOS blockchain. And what security level do you want? And what protocol is going to help you achieve it? In this case, you can choose atomicity, which basically means either all of these happens or it doesn't. If along the way I get an error here, the whole process just gets cancelled. Before proceeding into the final section of the video, we're going to talk about the platforms in blockchain so far, most popular platforms, and the required things for the environment that the blockchain needs. Some platforms are Ethereum, EOS, Lisk, and Ethereum uses Solidity, a programming language that we're going to talk about further down the line in this series. The current trends in blockchain are finance, identification, and web. This changes a lot of things because finance removes the middleman from the transactions. If you want to send money to someone right now, you have to go through the bank. But with decentralized finance, you remove this guy and you allow peer-to-peer transactions. With identification, a user like you and I can choose what data to share, and if you are going to charge the enterprise, the company, or the entity to share your data or not. With Web 3.0, everything is centered towards the user. That's really cool because basically the user has all the power. But still, there are limits and benefits to blockchain technology. The main limits is human negligence and bugs in the code, because a smart contract that performs a transaction or something can have a bug, an error in the code, and then it can lead to tremendous damage to the user account, to the user funds, as human negligence can. If the user sends money to the wrong address, well, he's screwed. Now, talking about the things that a blockchain environment needs: storage, communication, and computing power. The storage, keep in mind, that cannot have heavy things inside because it will make the blockchain really slow and therefore it wouldn't really work. But for storage, so far in some blockchains, they use distributed hash tables and Swarm and Whisper kind of thingies in the Ethereum blockchain. Swarm and Whisper are used in the Ethereum ecosystem. These protocols allow file transfer and propagation among nodes, so that they can store data and share data among each other. Each blockchain environment also needs a communication. In this case, we will be using the internet or something. Computing power is really important as well, because this thing is what provides the incentive for the blockchain and the miners and the people to keep using the blockchain. Because in tokenized blockchains, if there is no incentive, the project will die. The current mainframe technologies that blockchain serves for are smart contracts, logic that businesses or corporations or something the blockchain can use, so that each other persons and nodes can interact and make something happen. DOs and DAOs, decentralized organizations, decentralized autonomous organizations. Difference between these two is that this guy still has people involved, because people need to actually make things happen. That's why it's not autonomous. Autonomous means that an AI is running the system, and in this case, AI is not doing it. We also have AAs, which are autonomous agents, which basically is some AI code that does something for a user. DASs are decentralized autonomous societies. For example, a government can create a DAS that functions with DAOs and DAPPs to make a voting system happen, so that we, the people, the town, can know whether the election was really not corrupted or corrupted. DApps are basically decentralized applications, and they basically come in three types. All of these build on top of each other. The first one, the base case, the first kind of layer for decentralized applications, is a DApp that has its own blockchain, just for its own token and for its own application. The second type just uses this first layer blockchain of another blockchain. For example, let's say you and I create a decentralized application and we make use of a blockchain that already exists. This will be a second layer DApp because it's making use of another blockchain that was created for its own purposes. But second layer dApps are making use of this guy. And third layers is just the same. They just work on top of second layer dApps. As you can tell by the looks of the board, this is the final part of the video, which is the design of a decentralized application. First, we have the user, which connects to a user interface, which connects to an API, which connects to a blockchain. That is the main design for a decentralized application. The only difference with a traditional application is that in a traditional world, we wouldn't have an API or a blockchain there. We would have here and here a server, in a database. That is how blockchain dApps change from traditional applications. They have API and blockchain instead of the server and a database. After all, what is a blockchain? just a distributed ledger, a distributed database. What I want for you to take away from this video is the power of decentralization, that everything does not need to be decentralized, and the blockchain might not be the best alternative for everything, but in some cases, like in finance, identity, and Web 3.0, blockchain is really useful. Decentralized applications are really just applications that interchange servers for APIs and database for blockchain. If you like this video and everything, don't forget to click the like button, subscribe, and share with your friends. See you later. Have a good one.